All right, Christophe, good to see you today.
Yeah, me too.
All right,
Yeah, I'm all set.
great. Go for it.
So go for it. Yeah. So today I'm gonna talk about just 1 minute. I'm gonna talk about the CPU consumption and the spatial audio. And as you might already know, the computation of reflection and diffraction is quite complex, and sometimes it can require a lot of CPU. So at the moment, you can use this parameter here, the number of primary rays, to control the level of details you want in your computation of reflection and diffraction. And the higher the value you set, the higher the details you will have, but also the higher the CPU you will consume. And the problem with that is that the CPU performance for spatial audio is really related to the number of emitters and the complexity of the geometry. And so that means that if this parameter change during the game, which is obviously the case, you cannot use a fixed value and have a good solution for like balancing your CPU on spatial audio. So that's why in the new version, we have added a new feature that's called CPU limit. And basically, the CPU limit lets you define the percentage of CPU you want to allocate to the computation of reflection and diffraction. So let's say here, like you want to set the percentage to 5%. So you want to allocate 5% to the computation of reflection and diffraction. Then the system will continuously adapt the number of primary rays for you to maintain the CPU consumption around the value you set. It won't prevent all the spikes. So you need to think about the CPU unit more as a compressor than as a limiter. Okay, and when you activate the CPU limit there, so when you set a value different than 0 here, uh, then this value that you set there, the number of primary, it becomes an upper limit. So meaning that during the run, the CPU limit will not go beyond this limit. Okay. So let's see an example on how it works. Uh, so I play here. Uh, and first things I want to show you. So if you pay attention to these two curves there, you see the first curve is the spatial audio CPU consumption. And the second curve here is the number of primary rays, okay? And at the moment, you can see that the CPU is really low, and the number of ray itself, it's the max value we set in the setting, okay? So I start like adding some stuff, and you'll see how this curve evolves. So let's see if I'm going into the town, and now I'm adding like a new radio over there. Okay. And now I'm moving around, and you see as I move and as all this path there I computed, you see the CPU is going higher, and as soon as the CPU is going higher, you see the number of primary that is automatically adapt to compensate. So it helps you like keep the value around the target you have set. Okay. So that's really important because uh, it, it adapts automatically during the game. So you don't have to set a fixed value. And so you are guaranteed that your CPU will stay in this range. Okay. Uh, so that's what the system is doing. And I want to show you something else that is not like in this version. That it will be, it's a spoiler alert, it will be in the 21.1.1 version. And we added actually a bunch of like monitoring lanes specifically for spatial audio. So you have a bunch of them there. And I'll show you one of them, the spatial audio emitter process. And what this new lens allows you to do is to better understand when you have like a CPU like going up or down. It helps you understand why actually. So if you look at this curve there, where the CPU is going up, you can see at the same time that you have here like the number of emitters going up. So it explains why you get like this. Suddenly you get this drop in performance. I mean, you get this drop on the number of rays to actually balance the increase of CPU usage. So yeah, so basically that's what I wanted to show you. So a way to take control of the CPU you want to use for spatial audio. Thank you.
Thanks so much, Christophe. It's great to see the the balance. I think as developers, we know that we have to walk this line of performance and fidelity. So being able to expose that CPU limit, set that appropriately, and then, like everything in Wise, bring it back around to being able to profile and understand, some of the things that you're unlocking with these future features and features available today is that ability to understand the complexity of spatial audio and bring that accessibility to it.
Yeah, we're trying to abstract the complexity and just help people like give us the information when they encounter a situation, and we can help them debug or understand why and explain them, oh, this is why your CPU is going too high, and so we can help them like find solutions.
Exactly. It's
going in the right direction for that.
It's great work to be doing. I'm glad that the team is focused on bringing this level of accessibility for spatial audio, and thanks for presenting on those features today.
Thank you.
All right. Take care.
Bye-bye.